Of course, no section on trigonometry would be complete without some discussion of some of the applications of trigonometric functions. So one of the most basic things that we should do before we even get into it is, since we're in the area of right triangle trigonometry, let's get a little bit of our notation straight. Anytime I deal with a right triangle, actually any triangle, this is sort of a typical notation, it doesn't matter whether there's a right triangle enclosed or not, is that we call each of the angles labeled with capital letters like A, B, and C. And that each side opposite of those given angles is labeled with the small case letter A, B, and C. So side A is opposite of angle A, and side B is opposite angle B, and so on. So in this illustration right here, we're going to go with the custom that C is the right angle, and that makes side C the hypotenuse of the right triangle. Of course, we know how that goes. If we have a hypotenuse of a right triangle, a squared plus b squared equals c squared. So this fits with our normal thought processes on dealing with right triangles. So let's deal with what we've got right here. Let's say that we're told that we have angle B is given as 71 degrees and that side B is 24. And we're asked to solve the triangle, which is to say, find all the missing sides and angles. Well, to do so, of course, is relatively straightforward. If we assume, unless we're given other information, that angle C is 90 degrees, then what could we say about angle A? Well, that's right. A has to be the complement of angle B. And so A would equal 90 degrees minus 71 degrees. And if I work that out, that means that angle A must be 19 degrees. All right. So right now, if I'm looking at my right triangle right here, I could say, well, if this is 71 degrees and I've got a right triangle with angle C being the right angle, this must be 19 degrees. All right, so far so good. We're also told that side B is 24. Now it could be 24 centimeters, 24 inches. We're not sure, but it doesn't really matter for the purposes of this demonstration. In my right triangle, if I know side B, I can find out the information I want about sides A and C as well. For example, I know that if I have a right triangle, the tangent of the angle 19 degrees in this case, the tangent of angle A, will equal the ratio of sides A to side B, and B is 24. So to find side A, I'd multiply both sides by 24, and 24 times the tangent of 19 degrees will give us the length of that missing side A. Well, I worked this out before, and I found 8.26 would be the length of side A. Now, I could go a couple of different ways right here. One way would be employ my Pythagorean theorem directly, substitute in the numbers and work out what I get. But just by way of illustration, I'm going to show you that we can still also do a couple other things right here. For example, I know that if I wanted to find C and I wanted to use a ratio of one of my given numbers, I could tell you that the sine of my angle 71 degrees would be equal to the ratio of the opposite side B, right, divided by the hypotenuse C. Well, I don't know what C is, but I know what B is. So right here, if I say, well, let's take the sine of 71 degrees. So if I take the sine of 71 degrees, the sine of 71 degrees, and set it equal to 24 divided by my unknown length side C, then I could say that C was equal to 24 divided by the sine of that angle 71 degrees. Well, working this one out in my calculator, I find that means that C must equal 25.38 when I round the number. And so this would be the length of my side C. So if we're given any right triangle situation, it's good to know that we can use any of the given angles enclosed and the length of at least one side to solve for any of the other missing sides and angles in the triangle just by using our trigonometric ratios. And that's what we're going to do in these applications to come.